Let's see how quickly we can do merge sort with an array. This may take a little while. 5 class code. Let's see. KDR merge sort array. Let's see. What do we got? Where's our selection? Did I do another sorting one? Like, oh, there it is. Insertion to merge sort. All right. All right. So let's. All right, so we're going to have our little array right here. Okay. What do we want the array elements to have? All right, give me some numbers, quick.
1, 2, 3, 7, 8, 9, 10, 44. 2. 21.
1? 50. Sure. All right, great. So let's do tab new source array.hpp. If not defined. All right. Void merge sort and array. Perfect. And we actually need a size. Okay. Now I'm going to change this to a pointer so it makes a little more sense. All right, great. And it's going to do nothing, so that's fine. We're going to go and call merge sort on the array. The sizes, what is the size of this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's see if this works. Hey, it compiled. Now let's change this real quick. We don't want to call it LL test. Let's call it the array test. All right, so that's interesting. I printed out I, didn't I? Haha. No one caught that. All right, there we go. It's like, man, we sorted it already. Okay, there we go. So we didn't quite sort it. Oh well, that's fine. You okay? Sounds like we're having some issues. So, you know, before the sort and after the sort didn't do anything. Okay, great. That's because we haven't coded it. We had to set it up first. All right, what's the first thing we do? We cry. All right, let's go look at the. Yeah, divide the list into 2 sublists. Okay. All right, so we got int mid equals size divided by 2, and then we'll call merge sort on the first sublist. So how do we recurse here? Merge sort, passing in. Okay, and what's the size? Mid. All right. What's the other side? Merge sort the second list. So merge sort. All right. And then what's the size? It's gonna be close to correct. All right. If I were to run this, what's gonna happen? Yeah, we're gonna get a seg fault. Yeah, we forgot the return. If size is less than or equal to 1, return. All right. At least it returns now. Okay.
What if it's on?
Hmm?
What if it's on? Then it's not equally divided, is it?
No, not quite.
So shouldn't we subtract one from the
Yeah, these numbers aren't quite right, but that's okay. We'll figure out what's going on. This doesn't look right yet. And you know what? You can even do this. Oh, it even highlights it for you. Yeah, one of my favorite checks when you submit code is it tries to see how many times it sees the term to do, and if it does, like it sounds all alarms and flags. It tells you.
Hey, you still got something
Just before all that, could we just say like if mid is modulus 2 equals 0, and then subtract
We could fix it somehow. But let's see what's going on first. Merge the first sublist and the second sublist. Okay, well, how are we gonna merge this? Sort both sides. Well, they're already sorted.
Let's call them Oh.
Yeah, both lists are sorted because we just called merge sort on them, didn't we?
Yes.
Yeah, so they're both sorted, obviously.
Another function.
But if they're all sorted now.
No, the two sublists are sorted, but that doesn't mean the two. We have this right now up here on the board. We need to get that.
Let's call it merge and
Have a new function. Okay.
That's what I've decided.
I want to lead, but like, it's called merge sort. I'd like to merge in that one.
You want to merge? All right, let's go merge. Hey, no one's told me why this is not right.
What I was saying was doing inside like the merge sort function. Merge them inside the merge sort.
Hey, so let's do it this way. All right.
It's got merge in the middle. It should just do it inside.
All right, so we're going to merge, what, arrow comma, what's the size of this guy, mid? Yeah. And then, and mid as well. Not quite correct. Oh, y'all were saying that if mid is, okay, I see. So you're saying if offset should equal, I see what y'all are saying now. Mid mod 2. If it's odd, and then add that over here. Is that what you're trying to mention, Damon?
Yeah.
Wait, what does that do?
Probably not.
What's what do?
Oh, you just did the offset thing.
So if it's odd, add 1 to the size of the on the right. Now let's go see if it still compiles. Not quite. Probably because offset needs to be after the mid. Ooh, a seg fault. That means someone is getting too big. Yeah.
Mid plus 1.
What's that?
Very close.
Why would we subtract the offset?
I mean, one side is supposed to be bigger than the other, right? I mean, I'm assuming the left side is bigger.
Oh, you want the offset to be on the left side? Okay, we can do that.
Well,
And then we'd get rid of this. I don't think that's going to help any, but you know, why not? And we're going to not do that for now.
That looks incredible.
Hold on a second.
Very clear.
Yeah, this is very clear to understand. Nope, still seg faults. The easier way to do this is if size equals 2. We're going to return for now, but that should solve this problem. It does. Because the problem is when it's 2, it's going to, what's it going to do? You divide by that, it's 2, it's going to keep calling itself. So if the size is 2, then if, this is the easier way to do it, is less than, or I should say is greater than, then we'll just have int temp Oops.
So then you're just adding another element to make it even.
Yeah. There. Now we just take care of that case right there.
Should be array of 1 in the second line.
I'm sorry?
Should be array of 1 in the second line.
You are correct. Thank you. Perfect. Hey, look, it did something. We're already starting to sort. Awesome. All right. Now we have these two arrays and we need to, well, we haven't even called merge. Probably should call merge. Oh, we do. Great, we're done. Okay. How are we going to merge this? Hmm?
And the pivot and the quick sort, quick.
Wait, no, there's two parts of the array. We're getting a pointer to the parts of the array.
The size of,
and this-
of one.
What was the problem with the merge sort? We need to make a new array.
Increase the size of the first one by the size of the second one, and then just add.
No, because it's the same array. This whole thing is one giant array. All right, there's different ways to do that. I'm going to kind of cheat right now and just make a int buffer sub, I don't know, 1024. I don't know why I did 2014, but you know, that's kind of cool. All right. If you're doing this in a class, you'd probably create an internal static variable to hold this array for you as you merged everything. But I just wanted to create it up there just to make my life easier. So now what are we going to do? Well, we need to merge these two lists. So we're going to have let's see. We'll have int I equals 0 and j equals 0. Well, let's do the for loop. Right? So that's I will start from 0 to size 1, and j is going to go up to size 2. And then we'll have what? I is less than size 1. We want these outside of the for loop, I just realized. And this is going to make far more sense with a while loop, so let's do it that way. While I is less than size 1 and j is less than size 2. All right, so well, what are we comparing? What's the first thing we're actually going to compare? If
Array 1 of I is less than array 2 j.
If it is, where are we putting it? Into buffer? The new array, aka buffer. I didn't create a position variable. Well, let's go do that. And then we're also going to increment I, aren't we?
Or yes, you could also do it with
Okay. Kind of compact, but hopefully y'all can read this. While I is less than size 1 and j is less than size 2, if array 1 is less than, you're going to put that into buffer, otherwise you're going to put the other one in and then increment the two elements, yes.
Doesn't this lack the ability, like if you were to do all of one of the arrays, then it would just start messing up on the rest because you can't compare an index that is not there in the first array or for the first array because it's greater than size 1 for I.
Well, we're not done writing this function. I think that's, yeah, right. So this is the first part. After this function's done, what do we know? We've used up all the elements in one of the arrays, right?
check which one it is.
Hmm?
Do we check like which one?
Yeah, now we need to check which one it is. So if I is less than size 1, well, there's different ways to do this. Let's do it this way. If j is less than size 2, I'm lazy. Now I just write one for loop. There we go. Okay. If j is the one we need to pull from, let's pretend array 1 and I are actually array 1, are now pointing to the other array. Then just move everything over. what?
We need something with the buffer.
Yeah, we got.
And
So hopefully.
and if we have a void function and no references, how do we?
Well, we know that array 1 is actually the beginning of all this. So, I is less than size 1 plus. Actually, it's going to be less than position. I plus plus. Array sub I equals buffer sub I. We know that these two arrays are right next to each other. Okay? Let me write that up here, because that might be the confusing part. Because that's how merge sort works, is you're always comparing the elements that are next to each other. Let's look at the picture. Notice here, the 28 and the 35 and the 18 and 45 are actually next to each other in the array. There's no space actually right here. So once you get these guys sorted in a buffer, you can just copy it from the beginning of this one and it overwrites those 4.
Didn't you set error 1 to error 2 earlier? Wouldn't that mess up the?
Oh, it would. All right, fine. We'll do it this way. You're right. Ah.
What was the question?
I played with my array variables too early. So now we actually copy the right ones over. So here, copy the rest of the array over. And then finally, copy the buffer back to the main array. All right. Who thinks this is going to work first time? No? I'll vote? Okay. Got a little sympathy vote. Let's see what happens. Oh, it didn't even compile.
You let me down.
Oh, I told. Yep, definitely. Hey, that's why I asked the question. Hey, that's cool.
What?
The second one.
Did you not do anything at work?
Man, that 50 is being a jerk right now. But the rest of them is sorted. So actually, we're pretty close.
Yeah.
Yeah, we are close.
We just gained an extra number.
We gained. Well, we lost.
We lost one and gained
I don't
another
feel
one.
so much that I lost a 50 as I gained a.
An 11.
Can't you just like throw that one out? You know, the numbers two
It's like the bad
Do we have to have that number? Okay. All
I
right.
was doing that earlier.
So obviously we're doing some sort of out of bounds. If we're doing out of bounds, hey, wait a minute. Maybe Valgrind will help us out.
Yeah.
Thanks. Yeah.
GDB is just as
Wow, look at all that. Woo!
That's not good.
Oh, that's kind of cool.
It's on line 9.
Well, this is on merge sort 39.
Oh,
It doesn't like merge sort.
this thing, 'cause I got these errors.
What? Why would we be complaining about this? Oh, there's merge. Okay. Line jump depends on uninitialized values. I don't know where it's getting that from. Okay. Let's go. Conditional jump. Use of uninitialized value of size 8. That's going to be good. And where is this coming from? This is in main? So it says our problem's in main? I don't believe you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why is it complaining about that?
Make the size 13. Read the
Well, it's saying that it shouldn't be reading that, which is very confusing. But that's not going to help any. That's still going to have our negative whatever in there.
Wait, hold on. Can you go back?
Should it be 13?
Yeah, make it 13 because you start at 0 in the index.
Oh, did we lose 2 numbers?
Yeah.
Oh. 44 showed up twice now. Well, the other problem is we have this guy. See, that the 13's not correct. But at least you now know what's going on. He's pulling this guy over here, so that's why it doesn't make any sense. So,
No value in it.
well, I think Valgrind has what's the word? Betrayed us.
Yeah.
Yes, definitely betrayed us. Okay, we're getting some offset. Hopefully you can see what's happening by just looking at the extra numbers around. He's pulling some numbers over that shouldn't, which probably means that our offset and our mid and offset aren't quite correct.
But if you just
Hey, look, I had to do that, even said that.
No matter what, it's gonna be 0.5. So can you just like add 0.5? And then it'll take it.
Okay, yeah, that, I think you're on the right track, but let's go write this on the board and see what's going on. What's the initial size? 12. So initial size is 12. What does that make mid equal to? 6. And what does that make offset equal to? 0. All right, so we're going to call merge sort on what? Array, comma, passing in 6, and then array plus, what are we going to add to it? So that's plus 7.
Well, no.
Was that plus 1 really necessary?
No.
That's what I was wondering.
Yeah, I don't think that plus 1's necessary here.
Discard that plus 1 C4.
I like it when people say that.
Oh, yeah.
I was wondering that earlier. Like, why are they plus 1?
But that's, I feel like that's a little bit better.
You feel? I'm glad we can discuss your feelings with merge sort, and it's.
What if we just leave the value there?
Hmm?
He's our friend now.
All right, so plus 6. I think that makes more sense now.
Oh, you're right.
So that's the first error we had to fix. All right, now what happens?
No.
We're going to call it over here. What is size is 6? Mid is what?
Mid is 6. 3.
3.
And half.
And offset is.
You mind putting that on camera, Dr. West?
Sure, not a problem.
I'm kind of nearsighted.
And offset is 1. Uh-oh. I think that's our problem. Because we're going to call array, comma, 3. All right? All right. And then we're going to call array. Do we add the offset here? Oh, no, no. Plus 3, comma, 3 plus 1. Ooh, is that what we wanted? No. I think the offset's not quite correct. Well, I'm going to help you all out a bit. I think we meant size. Because then this becomes 0, right? Because now we're basing it off of size. All right, let's go look at this guy over here, because now we have arrays plus 3 to 3. And I think this is going to help us see what how this all works out. What do we have? We have 3, mid. What's the mid? 1, right? And offset is 1 because 3 mod 2 is 1. So we're going to call it on array, comma, 1, because that's the mid. Oops. Merge sort, oh, I'm not writing this out, sorry. Array, comma 1, and then we'll also have merge sort on array, should be plus 1. Hold on, let me help you out, Damon. Not a problem. Ooh, that was professional. Plus 1, and then it's going to be mid plus offset, so 2. Is that what we want though? I mean, that is what we want, because we want these two to add up to 3. But we had to switch which side is going to get the extra element. Okay. All right, let's see if that worked out. Hey, there we go.
How fun is that?
I think we actually got it this time. Hmm?
No, I just said that joke.
Yeah, hi, Joe. Oh, actually, hold on. Oh, no, we have 2 twos. Okay, good.
Yeah,
To the same thing.
That's right, guys. We have 2 twos in the array.
Perfect. Okay, all right, looking good. Well, that was fun.
I think we just maybe add manually.
All right, any other questions? Comments? Concerns? Screams? What should be this merge? All right. Obviously, this merge sort's not correct when you're going to send it to your professors, because what's your professor going to do first? What's the first test case your professor's going to do?
No.
No, thank you. If you're merge sorting null, do you need to do anything? No. Get out. All right.
Shouldn't your size be less than 1? Or are you gonna send in a valid size at the
Ooh,
same time?
ooh, I don't know.
Not immersive.
Oh, gosh. I
Yep.
didn't even hear that, but it worried me.
Yeah, it does. All right, anyways. All right, guys, here we go. Now, here's the question. We have 5 sorting algorithms. Bubble sort, selection sort, insertion sort, quick sort, and merge sort. Which one's the best?
It
Depends
depends.
on the situation.
Well,
Who said that? Thank you. Why? Depends on what?
What you do.
The scenario
Or
in which
whether you
you
want efficiency in one section or another, or that you depend on space or time complexity.
Oh, there we go. Everyone got that? Everyone got that? Okay.
The bubble sort is definitely the best.
If you just need to code it really fast, that's actually correct. But yes.
So with the merge for sort, the problems with the array is that it uses double the amount of
Memory.
memory.
Mhm.
But if we use linked list, then we have to iterate through it every time.
You have to iterate through. Oh, after it's sorted, you
Yeah.
can't randomly jump in a linked list, right?
So what if you had, but if we set a vector array or just an array to the, well, actually it would be vector array to the index thing, then it would be using double again.
Right. If you had a vector that was a copy of the linked list, again, you're using twice as much memory.
What if as you set the elements of the vector array, you delete what's it called, the linked list as you go along?
You would still need to allocate a continuous portion of memory, which is not something these systems are capable of doing.
So what do you mean?
You have your linked list, which has the nodes everywhere, right? And what you're asking is that when you take this guy, put him right here inside of memory, and then free up him, so that you'd be moving memory options. That's still, while that is kind of possible, that can get very complex, because if you only have in elements and you're trying to move them into a contiguous spot inside of memory, you're still going to end up having to allocate 2 in amount of memory.
Okay.
Oh, okay, I have a question.
Yes.
Okay, so why do we, if those are technically these 2 sublists of the same array,
Mhm.
are they not technically still the array?
Yes.
So why do we have to merge if they're still the array?
Because they're not sorted. Remember, this comes down. I'm going to get rid of this too, dude.
Can you have?
This is going to sort from array up to mid, and this is going to sort from array plus mid off to up to size. So it's going to cut in half, and these 2 are sorted. Just because those 2 are sorted doesn't mean the whole thing is sorted. Because this could be 1, 5, 10, 15, 20, and this could be 2, 4, or 2, 10, et cetera, et cetera.
Can you
So,
merge a quick statement?
what's that?
I don't know, I guess you wouldn't be able to do that.
That's why we just call merge afterwards. We need to merge the 2 lists that we know are sorted, because we just called merge sort on them. All right. Any other questions? Great. All right.